very basic algorithm, that is binary search. Binary search is a very helpful algorithm for searching in a ordered list of elements with a runtime of log n. So, given an array of integers nums which is sorted in ascending order and an integer target, write a function to search target in nums. If target exists, then return its index, otherwise return -1. You must write an algorithm of O log n runtime complexity. So binary search is a basic algorithm for searching which can be applied only when the given array of numbers or elements are sorted in some order, either ascending or descending order. So today we are going to write for ascending order. Now before that, let's see how this algorithm works. Suppose you are given an array of numbers sorted in ascending order, say 1 2 3 4 5 6 7 8, and we need to search if the number 2 is present in this array of numbers. So what we do is we will have 3 pointers. One is a left pointer and a right pointer and a mid pointer. So what we do is we split the array always into two halves, left half and right half, and search in one section to see if that element can belong in that section. For example, if we and mid value always will be the middle value of that section. For example, in this element, if we consider the left pointer to be at the start and the right pointer to be at the end of the array, the mid pointer will be somewhere around 4. So we will check if the target lies in this section or in this section. If the target is lying in the left section, that is left to mid, then we will discard the right section and continue the same operation in the left section, that is assign the left pointer as the start of that section and right pointer as the end of that section, that will be 4, and mid will be the mid of this, so that will be somewhere around 2, and we will see if that mid pointer contains the target value. For example, in the entire section, since we have divided it, the mid value was falling at 4, we will see if that nums of that mid is equal to 2. Since it is not equal to 2, we will see if it is greater than 2 or less than 2. So we can see that the nums of mid is actually 4, which is greater than 2, which means that in this ascendant ordered list, 2 will obviously fall before 4, which means that target that we are aiming for, 2, is lying in the left section, that is from left to mid section. So we need to discard this section entirely, right section entirely, because after 4, the right part of 4 will be anyway greater than 4, and obviously 2 will not lie in that section, so we will consider only this section. Now we will divide this into two sections, right section and left section and right section. So again we will check if that mid value is equal to 2. If we find that it is equal to 2, then we will immediately return that mid section or index of that mid, which will be the index of the 2, which will be equal to the mid value. So suppose we had one more function, then the mid value will be somewhere around here, and again we will check if the mid value is equal to 2. If it is less, then we will discard the right section and check in the left section. So basically what we are doing is we are finding the correct position or the section in which our target could possibly lie, thereby discarding the rest of the array. In that way, we are actually reducing the size of the array in the next iterations, thus reducing the time complexity to log of n. Let's see how we can do that. So we can do an iterative algorithm as well as a recursive algorithm. So let's see how we can code up the iterative algorithm. Okay, So as said, we need first a left pointer that points the start of the array, a mid pointer. For now let's keep it as 0, and then we will check, okay, because then as a right pointer which will be pointing at the last index of the array. Now we will go inside the while loop. We need to iterate over the nums and divide it into two sections, left or right. So always have to make sure that left is less than right, because you don't want it to coincide, because it's anyway two sections, it will never coincide. So when left is equal to, it can also happen that left and right coincide and we get that value. Then we will calculate our mid value, which will be equal to exactly half of our left and right pointer. Okay, now if we will check if nums of mid is less than the target. If it is less than the target, which means that it is lying in the left portion. If the nums of mid is less than the target, means the target is greater than the mid pointer, mid value, which means that we need to look in the right section. So we need to update left as mid plus 1. Okay, if nums of mid is greater than the target, which means that we need to check in the left section, which means that the right pointer will now move to the end of that left section. Else the other case is, it is nums of mid is equal to target, then we can return the mid. Okay, now after all this while loop has completed, still we have not found any if we have not encountered this, which means that nums of mid is never equal to target, which means that we can return -1, which there is no element which is equal to target in the list. So all the cases are accepted and we can submit this. Great. So in iterative method, the time complexity will be equal to of log of n, because every time we are like splicing the nums array into half and iterating over it only the half of the list, it will be log of n. And the space complexity will be, since we are not using any array to store anything, it will be O of 1. Only we are constantly using this, which is regardless of the size of the array, it will be the same, use of the same space. So this is the iterative method. Now let's see how we can write the recursive method. Okay, let's comment that out and write the recursive method. For recursive method, we need to define a function which we can call binary search, to which we will pass the num array, the left pointer, the right pointer, and the target value. So within this, this is our recursive function that we are going to call. Now if right is greater than equal to left, if right ever crosses left, then which means that we have not right is always greater than left, which means that we are still within the array itself. Mid will be equal to left plus right, that we are not crossing the boundaries. Okay, now if target is greater than num array of mid, then same, but instead of we are going to recursively call the recursive function, okay, where we will pass the num array again mid plus 1, because if target is greater means we have to check in the right section, which means that the left pointer will be now mid plus 1, right and target, okay. LF, same concept, we just need to invert the sign, then which means that it is in the left section. Binary search num array, left will be left itself, mid -1, target, okay. Elif target equal to this is actually not that it will consider, but I'm just writing so that it will be clear. Then return the mid value, okay. Else, after all of this recursive function, once it gets out of the recursive function, we have not encountered that return yet, then we have not found the value yet, which means that we do not have that value. Now we need to call that function. For calling that function, what do we do? Return. So we are returning the whatever value that is passed returned by this function is what we are returning, which can be either -1 or the mid value. We will call the nums value, we'll call the left value, we'll call the right value, and we'll call the target. There you go. It's submitted, it's passing. Great. For recursive method, the time complexity will be same as the iterative one, log of n, because we are splicing up the array each time we are recursively calling again to loop over the array. The space will also be equal to O log n, because in recursive function we are actually using up this array. Each time the recursive function is called, that amount of space is allocated for storing that instance of the nums array for that particular call. So we will be using that much amount of space also, but each time it will be half of the length of the array than before, so it will be O log n. That's it.